Well, first off, thank you so much for joining me, Pete, for this call, this quick interview. I'm really, really pleased to be able to speak with you, particularly at this moment, because of course, this is a time when there is a lot that is changing in the world of ESCs with FPV drones, with BL Heli 32 being withdrawn, and AM32 in many ways stepping up to take its place. So I'm really excited to have the opportunity to talk with you. We're going to talk about your background, how you got into developing software for the ESCs in our drones. Talk a little bit about AM32 for people who aren't familiar with it, some of the differences, some of the similarities to the other ESC firmware that we've had in the hobby before. We're going to talk a little bit, of course, about the withdrawal of BL Heli 32 and what that means for you and all the people who develop and rely on the AM32 software, how that's changing. And we'll have a chat about, the benefits of open source versus closed source software and things of that nature,
Certainly.
particularly as it relates to ESCs. And so with that said, let's dive right in. And I wonder if you could give us all an introduction to yourself and tell us a bit about your background and how you got into developing ESC software.
Okay, well, I mean, my name is Pete Smits, and I've been interested in electronics for a long time user before ever attempting to create or make any software or anything like that myself. My background has been in electrical repair. Now, so I started off years ago as a repair technician for generators. And that's where I really started learning about the three-phase process. And the basically a BLDC is really just a generator in reverse. It's all the same components are really there to either create power from battery, from the generator, or to make something spin with by providing power. And so that's what my background was in repairing generators. And then for years I've just been playing around in the hobby world, making drones. And I mean, back in the days we used to use Simon K firmware and 80 mega 8-bit flight controllers running I think it was multi-Wii at the time, and and they flew. They didn't fly great, but it got me interested in flying drones anyway. I would put together these giant monstrosities made of wood and 22 12 motors with 10-inch slow fly props, and go out into my yard and terrorize my neighbors with them. And so that's really what got me into it. Now, when I was making speed controllers to start off with, so a few years before I started writing AM32, I had a blog on RC groups where I'd release schematics for speed controllers based on BL Heli and BL Heli S and sort of Simon K firmware. And I was really interested in making the hardware for drones and for ESCs, and I was making flight controllers too at the time, just open source ones for other people to download the schematic or just print off the Gerbers and make their own at home. And then when BL Heli 32 came out, I thought, that's fantastic. We'll make better speed controllers using 32-bit MCUs. It's going to be wonderful. And then to my disappointment, it was unfortunately closed source, and I was not able to flash that onto any hardware. So that's what started me on the journey of writing my own speed controller software to work on the 32-bit speed controller hardware. And that seemed to have consumed in the last 4 or 5 years of my life now.
Yeah, I remember you telling me that you thought it was going to be quite a quick project when you started off.
Yeah, originally it didn't seem like it was going to be too hard. I mean, it's you just apply voltage to the right phases at the right times, and a motor will spin, right?
Yeah.
It's seems so simple. Um, so yeah, it seemed like it was going to be a quick project. The um, amount of variables and there's so many types, there's so many motors, so many different speed controllers, so many different hardware configurations out there that the process hasn't been as simple as I originally thought. It's now it's become um, yeah, pretty time consuming. It's almost like a full-time job for me now. I do spend sort of half my day working on the farm, and then in the evenings I grab the laptop, grab whatever ESC needs to be worked on, whatever motor needs to be looked at, and start spinning motors at night and fiddling with things to try to get them working better. Um, it's yeah, it's now I have to admit it's incredibly difficult. It's even writing basic um, for I mean. Bila Hali has been in development for years. Stefan's a really
Mm.
smart guy. I don't know if it's possible to write a firmware that is perfect for all situations, for all motors, for all ESCs. That's going to work great for everybody. And but we're trying.
You're giving it a damn good go.
We'll give it a go. But sometimes it's like playing whack-a-mole, where we find one problem and we fix it, and then in doing so, then inadvertently some other speed controller on some other motor that we haven't looked at in years, somebody comes on and says, oh, I tried the latest version and now I have this issue with this speed controller and this motor. And so then we go back and look at that one again and fiddle with things a bit more and try to get that one working, and then some other speed controller or motor combination, because we've made changes to those two to get them working, is now not working. So it's a constant process of trying to just dial everything in.
Yeah.
And we're getting closer and closer, but it's definitely not easy. It's
Absolutely not. So
yeah.
if people are interested to learn more about AM32, to find out more and perhaps support you and what you're doing with the project, where can they find you?
The best place is our AM32 Discord. So we are very active on Discord, and the right away, one of the things that we wanted to do to set AM32 apart was give everybody uh, the best customer service we can. And that's we didn't want to just set up a forum where somebody asks a question and then a day or two later might get an answer to the question. We wanted it to be, I really wanted to try to set up a community of like-minded individuals who can help out others with their problems too. And so we try to answer everybody on Discord. There's probably somebody out there who's shaking their head saying, "Oh, you never answered me." But we try to get everybody's questions answered, at least in a timely manner. Um, and our goal really is to, even if somebody comes on with help with something that we know is not related to AM32, it could be a tuning issue. We will try to help them anyway. Instead of just saying, "Hey, look, this has nothing to do with AM32," we'll try to at least answer their problems and answer their questions and then help them out best we can. And so the goal was really to it wasn't so much about the firmware, it was about trying to set up a community of
Mm.
with enough volume and enough people and enough other interested and intelligent parties to sort of help everybody out as they have problems. And so the Discord is the best place to get a hold of us. I'm on there all the time. It's if you ping me, my phone beeps. and I generally answer questions within a few minutes, or at least try to get a response. We look at every problem that is presented. So if somebody comes on and says this ESC is not working with this motor, we will do our damnedest to get that specific ESC hooked up to a motor and in the air and test it ourselves
Mm.
and see if we can help solve the problem.
Well, that's great. And I'll put links to your Discord down in the video description. And I think you have a Patreon as well, right?
We do have a Patreon too. Right now, it's a personal Patreon. We are now that BL Heli is shut down, we are in the process of trying to be a little bit more professional.
Sure.
So we are setting up a company, bank accounts, a business Patreon. Hopefully, we'll have some other options for anybody who wants to donate, which is great if you're a manufacturer, because we don't charge license fees. Because this does take a lot of we become the front line of customer service for the manufacturers and their speed controllers. So and it does take a lot of our time to help them out, even with just simple setup problems. So yeah, we will hopefully get all those things up and running soon. But right now we do have a Patreon, which will be distributed throughout with the members of the team. And so I also have to give a shout out to Unit. His name's Ike, and he has been completely invaluable when it comes to helping me work out issues with the configurator, with the website, and he's really keen on working with the project and seems to have the right mentality for working with AM32 as well. So he is also one of our main devs, and he's on the Discord all the time too. So definitely one, either myself or Ike will definitely be around at any point in time to help people out.
Well, fantastic. And I will certainly make sure that I link all of the stuff, all of the Patreons and all of the information that's relevant down below. So everyone who's watching this can find it. So I guess now that we've talked a bit about the background and about the project, the community that AM32 is, can you give us a bit of an overview of AM32 and I guess a bit of a comparison of AM32 to the other ESC software that maybe people are familiar with, BlueJay, BL Heli S, BL Heli 32, that sort of thing?
Yeah, definitely. Well, I mean, it's the big thing was AM32 is written for 32-bit processors. Now, we have before that there was BL Heli S, and BlueJay, which took over development from BL Heli S when the BL Heli 32 devs, BL Heli devs started moving to BL Heli 32. And BlueJay is a fantastic option for people who have BL Heli S ESCs and want to keep that up to date. They've been working on trying to keep it up to date with the modern bidirectional D-Shot features, extended D-Shot telemetry, and so BlueJay is definitely a great option for 8-bit ESCs. AM32 will not run on those ESCs. Those are written in assembly specifically for a specific family of processors, the Scilabs processors, whereas AM32 is written for ARM processors, although it also has been ported to RISC-V as well, so that we have that in development too. But we support a number of different processors with AM32, so it's a bit more universal when it comes to the processors that it works for, but it's written in C and it is only for 32-bit MCUs. So it really was meant to be an open source alternative to BL Heli 32. So we weren't trying to really create any groundbreaking new ideas at the time. We were just trying to make I was trying to make a solid, flyable flight ESC firmware for 32-bit ESCs that's comparable to BL Heli 32. So that was really the goal. Originally, it was I spent a lot of time with crawlers and ground vehicles. So AM32 was not written just with multi-rotors in mind. It was also written to be used for ground vehicles and especially the climbing cars or crawlers, where really low speed control is very important. So one of the features that we had at the very beginning that we implemented was a controllable sinusoidal startup, which was unique to AM32. And that is so with a sensorless speed controller, the motor has to be spinning a certain speed in order to create enough back EMF for the software to be able to read that and get the estimate the position of the rotor. So in the RPM that's below that threshold of back EMF, there's always a gap. So there would be basically brushless motors would start off at fairly high RPM, and there was nothing between 0 and its minimal starting RPM. And so there was a jump to that minimum starting RPM, a bit of a, with sensorless, it would seem like there's a bit of cogging at the beginning, because as the speed controller had to sort of wind up the motor blindly in order to get it moving fast enough, there would be a bit of cogging and a bit of rough starting up. So that's when a sinusoidal forced commutation was added to fill that gap between 0 RPM and the minimum RPM needed for sensorless operation. And it seemed to work out quite nicely for crawlers, as it gave a nice smooth startup. It felt fairly seamless, so you can just start increasing your throttle, and it starts off from 0 RPM. Once it reaches a certain point, the sinusoidal mode kicks off, and then it turns over to sensorless mode and keeps on going from there. So that was a feature that was unique to AM32. Another one was variable PWM frequency at the time. So now it's been implemented in BL Heli 32 since then, and other firmwares. But that was another firmware feature that was introduced with AM32, and it was a feature that allowed the it did a couple of things. One, it allowed the motor to help avoid some commutation interference with PWM frequency. So when PWM frequency and commutation frequency are getting fairly similar, close to the same frequency, they can align and cause some sort of throttle disturbances. So variable PWM was meant to get around that. And then it also helps sort of work almost like a little, it sort of does some dithering too, because it'll sort of adjust the PWM frequency up and down. And it seems to help smooth things out. And then also for smaller motors, they tend to work sometimes better at a higher PWM frequency. There's been various, you've probably done tests too, and showing how PWM frequency can affect the sort of torque and response and braking response of smaller motors. So sometimes it was advantageous to start off at a lower PWM frequency, and then as the RPM increases, go to a higher PWM frequency and drop down to a lower one when braking hard. And so it had some advantages, but sometimes things work better on fixed PWM frequencies too, but it's just an alternative. It's an option that's there for people and can sometimes help out quite a bit.
I think the main benefit of lower PWM frequencies is better braking performance. I've certainly seen that a lot. Once you get much above 24 kilohertz PWM, you typically start to see the speed at which the motor is able to decelerate, reducing noticeably. So I think that's the main benefit of it being variable, is to have that low PWM frequency for braking. Yeah.
Oh, and some motors start up a little bit better with a lower PWM frequency too. Depends on the motor, and then that's why we have so many options, because there's you can try one motor and then switch to a different motor, and you might need to change a setting and find it works better at 48 kilohertz instead of 24 kilohertz.
Yeah.
It might there, depends on the electrical noise in the system too, the current ripple throughout the ESC. There's all kinds of variables. So sometimes it just takes some experimentation, and so you might just have to play around with PWM frequency until you get a frequency that works best for you.
That's certainly what I've been finding with my testing. I made potentially it might have been a mistake. I went all the way down and tested, I think, 8 to 16 kilohertz PWM frequency.
Oh yeah.
People will see. People will have seen in the AM32 testing video that I managed to burn out all the current sense resistors on my thrust test stand.
Oh really? From the
at 8 kilohertz, yeah. So obviously, just that ESC was able to draw a truly staggering amount of current at that lower frequency. No problem at the high, no problem at 16 or 24K as the minimum, but 8 was obviously a different kettle of fish.
Oh well, the on time will be fairly long at 8 kilohertz, and yeah, so the instantaneous current and the current ripple can be massive.
Yeah.
It's actually starting off from low RPMs anyway. So
I wish I'd had that conversation with you before I did that test. I might not have done it.
Yeah, no, the lower PWM frequencies are really meant for much larger motors that have a higher inductance, and so you don't see as much current ripple with them. These little drone motors have got such low resistances and such low inductance that they're basically a dead short at low RPMs. So yeah, you'll see sometimes 150 plus 200 amps even on a 22 something size motor accelerating from standstill. So
I've got to hand it to the
quite
ESC
shocking,
because the ESC was totally fine.
Oh yeah,
no problem. Yeah, it was fine.
yeah. The good old SkyStars KM55 was
that's
it?
the one. Yeah.
Oh yeah, those are bulletproof ESCs. Yeah, they seem quite tough.
They're incredibly durable. Yeah, I mean, I've done some. People would have seen. I mean, I've done horrible things. A lot of flywheel tests, which I think are among the worst, where you're asking the motor to accelerate a large inertial mass. So you actually are demanding maximum torque at low RPMs, and then continuing to demand maximum torque all the way up, for several seconds. And I mean, I can burn motors out very easily on that sort of test, but I've never had any issue with the ESC. The ESC's always been totally happy to do test over and over again.
We've had our fair share of little issues come up here and there with the KM55, mostly my fault. But the ESC itself seems to actually be pretty strong. We haven't really had any reports of them vaporizing themselves or burning out MOSFETs or anything. So luckily, they've seemed to have been pretty good for that.
Yeah, well, certainly I've been impressed because I've killed quite a few ESCs on my test stand. But I've been running the same KM55 for months now, and just ever since I started using it, it's been fine. So yeah,
fantastic. Yeah,
very good. So I wanted to ask you a little bit about the withdrawal of BL32. You probably have a better feel for this than almost anybody else. How do you think this is going to impact our hobby? How is it going to impact FPV, and how's it going to impact the manufacturers that we rely on for components?
I think for most people, it won't really impact them at all. I mean, most people, they buy a speed controller, and most people don't even update it. If it works, they put it in their quad, they fly it, they enjoy it. They don't care what it says on it, as long as their quad is flying properly. And then there's the ultra hobbyists, like you might be in that category, and myself, where we analyze things to death, and that's part of the hobby too, is to sort of really examine things with a fine-tooth comb. But For most people, I don't think it's really going to affect things. They they'll just buy a speed controller that has a different name on it, and hopefully they'll put it in their quad and it'll fly well. And for we've had enough flashes of AM32 now that we know that 9 out of 10 people are going to have a fine experience with it and not have any issues. And 1 out of 10 people we might need to do a little bit fiddling with. They might need to come on the Discord, ask some questions. We might need to, change the firmware a little bit for that target. But we're working through those as they come up. But for most people, I think that the hobby is going to be just fine. It's not really going to affect things that much. I was sad to see BL32 go. Actually, I like Stefan. I think he's doing a wonderful job with BL32. I mean, I was always trying to meet his bar that he's setting out for performance with AM32. And it really is a shame that it just closed down so suddenly.
Yeah.
Especially for people who are not able to update. If there was even just a little bit of warning that, hey, we're going to shut down in a month, update your ESCs to the latest ones, test them out, make sure they're good because things are going to go offline. But we're getting a lot of people on the Discord who are like, oh, I've got BL Heli that's on 31 point something or 32.1 or 32, and I need to update it and I can't do it anymore. And that's a shame that
It is a
there
shame,
wasn't
yeah.
a little more because flashing BL Heli 32 ESC to AM32 is not the easiest process. There, and especially when it's not an ST micro MCU, it's you need you need to mess around with debuggers, ST links or AT links or GD links for Giga devices. The ESCs are write protected and readout protected, so option bytes have to be set. The ESC
Yeah.
has to be made writable before you can even get to the stage of flashing AM32 onto it. And honestly, we spend more time getting through that, walking people through that process than the AM32 flashing process is, just to use the ST link to get the ESC to a writable stage where it's blank and ready to be flashed with a new firmware. So it would have been nice to, have a little more warning that this was coming, so that we could have, so people could have updated their speed controllers. But it is what it is. It's done now, and so we just have to sort of roll with the punches and just
Yeah.
try to do the best we can with helping people who want to flash their ESCs with new ones. But we're also advising people too that just because they can't update their BL Heli 32 ESC, if it's flying fine now, there's no
Yeah.
reason to update it. There's no if just keep on using it and enjoy it, and it's going to keep on working forever. So it's there's unless you're really curious about trying AM32, your quad's not going to fall out of the sky
Yeah.
because
That's what
BLE
I've been
32
telling
is shut
people as
down.
well.
So
That's what I've been telling people as well. I mean, honestly, I'm saying, if you want to try AM32 out, the best thing to do is to go buy an ESC with AM32 on it, because
yeah,
then you'll have just an easy, very smooth process to update it if you want to update it, to try out the different settings. But yeah, it's a lot of time and effort to invest in trying to flash a BL Heli 32 ESC to AM32. And if it doesn't work, you might brick it. Yeah, whereas it's easier
yeah,
and takes less time just to go pick up an AM32 ESC, and then it's just a case of plugging it in. It's all working there for you. So,
yeah, and that is it's heartbreaking actually when people come on and they've got an ESC and they say, oh, I want to go through this flashing process and try it, and they might do 3 successfully, and then a loose wire or a misplaced connection, all of a sudden,
Yeah,
yeah,
there's
and
a
then
risk.
then they damage one of their ESCs, and then that's it. They just bricked their 4-in-1 ESC. I actually have a bunch of sort of promo ESCs and tester ESCs that
Yeah.
if it's I send them to people if they really mess it up, and I don't have too many of them, but it's I've sent out a lot just to just because it feels so bad that if somebody they want to try AM32, they mess up their hardware, and it's like, okay, what's your address? I'll send you an ESC, and
Oh,
oh,
Pete,
how
that's
come
very,
people?
very good of you. So what about manufacturers? What's the response that you've gotten from manufacturers? Do you think that some of the larger manufacturers are going to be adopting AM32?
I don't know. Um, there's a lot of them that have approached us, and everything has gone well. And those ones, they will have AM32. It's the first impressions seem to be everything when it comes to flashing AM32 on their products. So we've had some manufacturers. We're working with TBS. Aokoda, Speedix, SkyStars, and we've had great responses with their ESCs. They've asked for firmwares. We've sent them a test one. They tried it out. It flies great. They've had no problems. So we've made them targets, and it's going to be great. And then there's the manufacturers that might flash it, and it doesn't work the first try. And
Mm,
we haven't seen the hardware. We don't know what motors they're testing on. Some of them are incredibly frustrating because they will even send us an ESC. I will put it in a quad. I will put it on 6S. I will try a number of different motors. I will fly test it. I will do whatever I can to try and make this ESC have a problem, and it will work perfectly fine for me. I send them the firmware, and they fly it, and they're like, "Oh, it has this. I saw this glitch, or there was a desync here, or it seemed like it had a misstart here." And I could try for hours and not produce the same problem. And it's like, where do I go? Which bits do I start fiddling with when I can't recreate the problem here? So and so
in that
some
case, it might not
manufacturers,
be your fault. In that case, it
well,
might not be your fault. It could be a
and
loose
it
wire
could
on.
be that it's just that particular hardware.
Yeah.
So I don't know whether at that point in time it could be a motor that's not functioning 100%.
Yeah.
It could be the ESC itself that's not functioning 100%. Yet the one I have on my bench is working fine, and we just don't know. And so you know, most of the manufacturers are great. They will flash AM32 to a bunch of different quads. They will go out and fly test a number of different motors and a number of different quads and a number of different ESCs, and then they will get back to us with feedback and say, okay, this worked great. This one, maybe has needs some work. Um, some manufacturers will only flash one ESC with one group of motors and one
Yeah.
tester, and that's all they will do. And if it doesn't work, that's it.
That's it. They'll
We
wait
have to
for someone
keep
else
on trying
to.
until that one tester is happy. And because there's so many different MCUs right now too. We
Yeah.
AM32 runs on the FO51, FO31, the Giga devices E230, the Artery Tech F415, F421, ST Micro L431, the G431,
Just.
and they all run the same code base, but they're not all going to be identical because they all have slight differences in their hardware itself and their peripherals, and their comparators are slightly different when it comes to sensitivity. One might have more ADC noise. The
Yeah.
F4s don't have calibrated um, temperature sensors, for example, and they aren't going to make any sense. And it's so what might work perfectly fine on one with the same with the same software revision might not work on another ESC from a different MCU as well. So we're trying to get through those issues, but over the past week it's been rough, to say the least, because I mean there's just been so many new targets, and a lot of this we're working blindly before they even arrive to us.
And that's the benefit, right, of being, if you're looking at a manufacturer like SkyStars, who got in early doors and was one of the first manufacturers to take on AM32, no doubt they're feeling in a much better position because they're much more familiar with it. So yeah,
and they
the benefit of being first.
and they know the numbers too. It's if it's your very first AM32 ESC and it doesn't work, you're going to assume, of course, that all AM32 ESCs don't work. But if you have 10 quads that fly AM32 and they all work fine, then yeah, you start to get some more confidence in it. But then there are those people that are going to be the very first time they ever try it on an ESC, it might not work the way they want it to. And so come on to Discord and let us know. And the best thing you can do is get black box data. So we hear all kinds of descriptions, about this motor makes this noise like a chimpanzee when I accelerate, or this makes a screaming noise when I decelerate. It's like, it's hard to
you need some logging.
Guess what that could be. Like, get a black box, and that's the best way to, especially now that the latest beta flights and with version 4.5, and especially the Black Box Explorer, they record RPM telemetry by default now.
Yeah.
So it's now something that we can see, and that is one of the best ways that we can troubleshoot issues, because now we can see what the motor output is, but we also have feedback from the ESCs itself too, so we can see how the ESCs are responding to the motor output. And so that is, we can see if it's a desync right away. We can see if it's a motor stall because it's reached too low of an RPM. We can see what that particular issue is. So, if you're going to go on for support, just do a quick flight, get a black box log, and then come onto the support channel and let us know with the black box data, and then we'll take a look at that and see if we can help solve the problem.
So much easier to diagnose when you've got that, because you can see things like you say, the motor's commanded to full throttle, but the RPMs aren't increasing, or things like that, and you go, oh, okay, so that could be desync or a damaged motor or whatever. One of the ones that I've always found that I get, I don't know if you get this as well, is loose props, or slightly loose prop on one motor can really throw some pilots, I think, particularly maybe newer pilots or pilots who haven't hit the issue before, like, can really throw them for a loop, because they're like, it makes a horrible noise and the quad wobbles, and it's, you think it's something to do with ESC or the motor or the flight controller, and it's actually, that was one that I had earlier today, a loose prop nut, or slightly loose, just loose enough so that on a very fast acceleration or at very high throttle, it would just start to slip.
And it's, I mean, sometimes we find the tiniest little thing, like we'll, in the black box, we might see a slight gyro noise, which is odd, like a little tick every once in a while, and we might find that it's actually just a physical, like, it could be the balance lead sort of flapping in the breeze, and every once in a while it connects against the quad, and it only takes a tiny little tap from something loose or a wire for it to be a fairly noticeable impact on the quad, but you don't notice it because you don't see the balance lead in your goggles. And it's so we have that quite often too, where it's something just loose on the quad.
I've had that, or even like signal wires tapping on the gyro chip, I've seen as well.
Yeah,
like
yeah. Signal
just a
wires
loose
that aren't
wire
that
tapping
are
on a
loose
gyro.
and flapping in the breeze,
Mm.
and it can make a huge difference. So yeah, so the black boxes are invaluable. That is the best way to help us out. Anyway, it's a blurry camera video of the quad falling from the sky.
That's more
Doesn't
difficult. Yeah.
It's a bit difficult, yeah, yeah. So, get us black boxes, and then we're golden.
So AM32 is proudly open source. Um, how do you think? What do you think the kind of benefits or the advantages and maybe disadvantages of being open source compared to a closed source alternative? And obviously, BL32 is the obvious example, but there are lots of other ESC manufacturers that have their own closed source ESC firmware as well.
I think there's advantages and disadvantages of being open source. Um, the the advantage is you get more eyes on the source code. So you can get more help with the problem, and you can get more experts who can take a look at the source code and maybe notice something that we might have missed. And especially when it comes to little things, typos here and there, or just one off by one problem or something like that, that we might never notice because we
Mm.
might not go back and just having lots of eyes on the source code definitely helps out. Um, I think one of the biggest advantages I mean, for anybody who's developing their own hardware, of course, there's major advantages. You don't have to petition one of the closed source developers and try to pay their time to create a specific target for
Hmm.
their hardware. So AM32 has been flashed to by now hundreds of different DIY ESC projects.
Mm.
And so that is a major advantage to be able to just create your own target, build it, and flash it to your own hardware, and away you go. You don't have to contact anybody. You don't have to worry about license fees, and you don't have to worry about the firmware that you're putting on your hardware being a black box. You can go and look at the source code and see what it's doing and fiddle with things. The disadvantages can be in the making sure that the hardware is suitable for the firmware that's being flashed to it.
Mm.
Whereas if you have a closed source software, you could say, okay, send me the hardware first. We're
Yeah.
not going to touch it until the hardware gets here. We're going to make sure that we validate that hardware properly and test the
Mm.
hardware. Whereas we hear about things the other way around, where we don't find out about a problem until it's like, oh, we flashed AM32 to our hardware and it's
We
not
made our
working
own
right.
target. Yeah, we made
It's
our
like,
own
well,
target.
like what we don't like we don't know anything about it.
Yeah.
It's like, so they're and so it could be released on substandard hardware that
Mm.
we might not necessarily want it to be released on, and we might refuse to even make a target for that hardware ourselves because we might have tried it and so we decided, no, this hardware is not worth making
Mm.
an official AM32 target for, but yet it could still be. And there are ESCs on AliExpress that you can buy that we've never seen, that they flashed. If you hook them up to the configurator, they show a generic target made for a different ESC, and the company just makes them, flashes them with a generic target, sells them, and then the customer service is up to us because they say AM32 on the ESC. So that's tricky sometimes because
Yeah. I can see it being tricky. How would someone know which ESC to pick? Is there a sort of, I guess, is it a case of looking through the list on the GitHub and making sure to pick an ESC that is an official target?
yeah, well, I mean, generally the the ESCs and the manufacturers who are making specific hardware for AM32 will generally print that it's in on the PCB or on the the heat sink or something like that, or on the shrink wrap, that it's actually an AM32 ESC. And I would go onto the website am32.ca
Hmm.
and take a look at the downloads list and see that's the best list of all the hardware that's out there. And if you see that ESC is one of the ones that has its own target
Mm.
and its own firmware for it, then it's pretty safe. It means that we've looked at it, we've checked out that ESC, and it should work fine.
Yeah.
But if it doesn't, then come onto the Discord, ask about it, and send us a link of which ESC there is, because there are some generic ones out there which, and they actually might be perfectly fine ESCs. We just
Mm.
don't know anything
But no
about
one
them.
knows anything about them. Yeah.
No, and people are buying them, and sometimes the manufacturer won't even send them to me. It'll be an individual user who will order a bunch of ESCs and then ship them off to one of us to take a look at
Just to
on
see
to
what's
try
out
to
there.
get a target for the manufacturer. And it's like, well, they should really be the ones doing this. But oh well, if it works, we'll make a target for them, and if it's quality ESC, we'll come up with a target for it anyway. Because I'd rather have something that works than something that half works,
Yeah. I
especially
mean,
if it's
that's the type of customer service you only get from an open source project.
yeah.
No one else is going to go to that level of effort. So you're doing the Lord's work there, Pete. um, so we talked a little bit about AM32 as it is now. Can you speak a little bit about the future plans you've got for AM32? Any new features or new ideas or new hardware that you're sort of looking at into the future that we might keep our eye out for?
Well, we are eventually going to be releasing a fairly large update. We've got an experimental branch of AM32 right now, which we are going to be adding quite a few features that give people more fine-tuned control over things.
Right.
Things like changing their rates of acceleration to whatever you want. You can accelerate from full speed up to taking 10 seconds to go up to from 0 to
Okay.
full throttle if you want.
Hmm.
Changing minimum duty cycle levels, cutoff levels for low RPM throttle protection. So many more new features. CRSF inputs to more telemetry outputs.
Wow.
We've got programming by CRSF radios coming up too. So those with this is just going to be for TBS radios at first, because they're the only ones that really use the full CRSF protocol.
Hmm.
But you'll be able to use their radio to adjust settings on the ESC.
Cool.
So we have quite a few features coming out in the future. We are going to be working on, well, I am hopefully going to be able to spend some more time on what we've discussed before, which was a
Sure.
simple field-oriented control type of control,
Hmm.
where we are using current instead of back EMF feedback to do a rotor position estimation. But right now, because of what's happened with BL Heli, everything's just sort of been put on hold, and we are just working through the mountain of to-do list that we have right now, which is just an ever increasing list at the moment of new targets to try to get through and new manufacturers to start working with. So we are
Absolutely.
just trying to get through that first of all, and then will hopefully reach a point of stability where we can get back to the things that I love to do, which are to uh, experiment with the hardware, experiment with the software, and try to keep pushing things forward. But yeah, unfortunately, right now it's
all hands to
everything's
the pumps.
yeah, it's right. We're just trying to try to stay on top of of new things and to keep up with the support on the Discord. So
Absolutely.
that's the primary goal at the moment, is to try to make the transition from BL32 as seamless as possible for manufacturers. So
Yeah,
that's where we
absolutely.
are at right now.
Well, on my side, I'm going to just keep plugging away and working with manufacturers to get you development hardware for that. I imagine that is still a few weeks away from being able to get some development hardware to start working on that new in-phase current sensing solution. But well, I'll keep plugging away at it, and we'll get that to you as soon as we can. And then, you know, obviously, as you said, you work on it when you have time. But I'm just happy to be able to help and contribute something to the project, because I think that would be it'll be pretty cool if that feature can deliver, you know, the improvements in power and efficiency that we think it might be able to. That would be a nice thing to have.
Yeah, no, it's definitely something that I'd like to get back to, but right now we just have to deal with the tasks at hand, and there are many of them. So you know, it's a stressful time right now. Honestly, I find this very stressful at the moment, because there's a lot going on, and it's very unforgiving work, because it's not like an error message that pops up on a Windows PC if you make a mistake in your software. It's, you know, a quad that falls from the sky. It's a piece of hardware that might get burned. It's,
Yeah.
you know, it could be dangerous for somebody if there's a signal issue or a spool up or something like that. So, you know, I find it very stressful at the moment, and um, we're just trying to work through that at the moment.
Yeah, I completely understand. I feel the same way. I think particularly when you're trying to provide something to people, and you're hoping that they have a good experience, but there's so many people using you know what you've made for us. There's always going to be some people who have problems, either because they're running very non-standard setups, or because there's some other issue that's not firmware related. So a lot of
There's
that.
firmware related issues too that, you know, we have to solve, and we rely on people to find those problems, to report those problems, and tell us. The worst thing you could do is have a problem, not let us know, but
Yeah,
go on to every other forum and let everybody else know how bad of a time you had with. And that's happened in the past too, and is very stressful. Where, you know,
yeah,
we'll hear third hand from somebody else. It's like, oh, so and so tried it out, and
had a
this went
problem.
wrong,
Yeah,
and it's like, well, you know, we've got GitHub. They haven't reported an issue. We've got Discord. They haven't come on here and said that they had a problem. So, you know,
yeah,
we aren't going to go fixing problems that we don't know exist, because they've got to get the word to us first of all. And then
well,
I've hit some pretty low points over the past couple of weeks, because the number of users have shot up exponentially.
yeah,
And so all of a sudden I'm doubting everything that I've ever been confident in, and thinking, oh my God, I'm just picturing quads falling from the sky all over the place. But it's still the same percentage probably of people that are happy, but you know, on
yeah,
Discord, we don't tend to see those people. Everybody who buys an ESC has a great time, has no issues. We never hear anything about. So, you know,
yeah.
if you've tried an AM32 SC and you have a great time too, come on to Discord and let us know.
Yeah.
Give us a little bit of confidence too. So it's
Yeah, absolutely. Dilute a few of those troubleshooting messages. Yeah.
yeah, exactly. But no, we will solve the problems. I won't rest until we do.
Well, all I
So,
can say is that I've flown a lot of AM32 ESCs, and I've loved every single one of them. And I have been shocked at the amount of abuse that they will tolerate. And um, lots of other ESCs running lots of other firmware that I've tried haven't been so resilient. So certainly you're doing something very right.
Oh, I appreciate the confidence boost there. Thanks.
Absolutely. And I'm going to keep doing all of my testing, and if I do find anything different or untoward, I'll certainly let you know. But nothing, touch wood, no problems so far. I guess just to finish off and close out this conversation, what advice would you give to people who are aspiring developers and want to contribute to open source projects, either an existing one like AM32 or to do something new? What advice would you give them? What have you learned?
I would say, oh boy, for new developers getting into the allow way more time than you ever think that you're going to need for the project. Be careful about, and I was probably guilty about this first of all too, be careful about pointing out flaws in other people's projects, for one.
Yeah.
Because you will have the same problems later on down the road in your own. So,
Absolutely.
and then you'll find you might have to do some of the same fixes that you've been criticizing other projects for having in your own to begin with. So, although you might start the project with full confidence, sometimes there's almost a period of regression, which is hard to deal with, where sometimes the best performance you might get is on the very first revisions, because you might work on only a single motor, a single piece of hardware, or a very, very small select group of hardware, and you can have massive fast ramps for acceleration and not have desyncs and no issues, and so you'll go on and say, hey, this is my firmware doesn't need these things. It doesn't need this throttle protection, doesn't need ramp up, it doesn't need low RPM protections. And I think I might have said a few of those things myself when I'm starting up. But over time, because there's as the number of supported targets grow and the number of variables get bigger and bigger, and you might find you end up doing the same things that you're criticizing other people for. So if you're just getting into it, just maybe ask people, hey, why did you implement these things first of all? Because it's you don't want to dupe people into a false sense of security by putting down somebody else's project. So it's great to promote your project on its own merit, but you never want to promote it by saying, oh, this one is terrible because of these reasons. Mine doesn't have these.
So it must be better,
Because
yeah.
you never know what might happen later on down the road. That you might be implementing those same things that you're upset with the other firmwares. But I would encourage anybody to write whatever they can, and especially when it comes to writing their own firmware for speed controllers, it's a lot of fun. It's very rewarding because it's such a puzzle to solve, and it's such a even getting that first motor spinning is so tricky. And then when you finally get it, you will feel on top of the world. And so I really encourage people to not, get some test hardware, get some debuggers, and try it out, and look at some of the other open source softwares that are out there. And then if you discover something that is that's better, then that's great, especially if it's open source, because competition only helps out everybody. So if somebody, I know if one of the other open source software comes up with something that somebody comes to me and said, hey, we tested this and this is better, that gets a fire lit under me to start.
It's just a pull request away, right?
Yeah, that's right. So it's so have at it, and so the more people we can have working towards just making motors spin properly is going to help out the users. So
Yeah.
and yeah, just go at it. That's all I could really say.
Yeah, and now with AM32 hardware out there, people could develop their own software on your AM32 hardware, right? Because it's all open source. They can build and flash their own firmware to it.
That's correct, and they can even use since the AM32 bootloader is not locked and it's open source, they can keep the bootloader and actually use our config tools to upload. So if they came out with their own firmware, they could flash it just through our config tools. So
Yeah.
it definitely makes things a lot easier. So we can swap between different open source firmwares.
Yeah, and that's brilliant. And I know that's the sort of thing that allowed projects like Butterflight back in the day and Emu Flight to get up and running quickly. Is that you start with you fork one project and then you develop in a different direction, but you can rely on all that infrastructure that's already out there. All of the configurators, all of the hardware. You kind of have all of that to support you. So I think, yeah, that's another big benefit for people who are looking to do it themselves. Last question is there anything else that you would like to share about, what you're doing, about the firmware, about what your plans are for the future? I think you've covered so much that I haven't got any more questions.
Yeah, I think that we've pretty much hit all the major points anyway. It's a matter of just getting through the new targets for now, working with new manufacturers, and hopefully getting hardware back out into the market so there's no interruption for users who want to buy a speed controller and go fly quad. And so that's really the goal right now, is just to make sure there's hardware out there so people can use it and we can keep having fun with our toys.
Absolutely. Well, Pete, I can't thank you enough for taking the time to have a chat with me. I've really enjoyed this conversation. It's been a really lovely hour, and I hope that you've enjoyed it as well. I'm not going to take up any more of your time because it sounds like you're super busy. But I just want to say thank you so much for everything that you do for everyone in the FPV community. We really all appreciate it.
Oh, well, that's very appreciated, and thank you too. I mean, you're working tirelessly at it too every day, and your
Sometimes too
testing
many
and
hours, it feels like.
it's been so valuable. I don't know how many Chris Rosser quotes and snippets and things like that I've seen, with and screenshots from YouTube videos. So it's that testing is so helpful for all of us too. So
Well, I'm
that's
going to keep
wonderful that you're doing that.
working on it, and I've got a whole video series that I'm working on, some of which will probably come out before this video, taking people through the new AM32.ca configurator, how to update, how to flash, how to do all the settings, and then I'm going to be diving deep into trying to find the best settings for the different motors, larger and smaller. So yeah, I'm excited for that.
Yeah, 12S is that's the tricky one right now. It's the 12S ESCs and big motors, and we just haven't worked with them at all. And I'm just starting to develop with them right now, but it's a whole new ball game, and it's we haven't really had a lot of settings like ramp ups and throttle restrictions and acceleration restrictions and things like that, and we really do seem to need those when it comes to these big motors and big props and really high voltage systems. So
Right.
that's the next frontier, is to try to get these working.
Yeah, and all I would say is that given my experience, even some of the commercial solutions out there for 12S are not as reliable as you would want them to be.
No, and that's yeah.
Yeah. So I was having a conversation chat with Luke Bell, who's the world speed record holder for quads, and he says that he had to test, I think, 12 ESCs, and he blew up 8 of them, and then 4 worked.
Oh, really? Yeah. Well, that's
so Yeah.
Yeah.
Yeah, he
So
was
I mean,
doing
that's what
the
I'm getting
quality
to now
control of
is I've got these speed controllers that, some people have said to me, oh, we tried a T motor ESC with this motor and it desynced. We tried a fly color one and it desynced, a 12S. We
that. Yeah.
tried a iFlight one and it desynced. Can we flash AM32 on them? It's like, oh my God. It's, if Bill Heli couldn't do it with that much work,
Yeah.
it's going to take us the same amount of time and effort, if not more, to get to that stage, as we just haven't worked on them at all. And it's really tricky. I mean, you're dealing with such massive changes in voltage so fast and such large currents that, yeah, we're on a knife's edge between flyable and exploding. And so
Yeah. That's it. It's everything's running so close to the limit, right? With those big motors.
yeah, and
Oh,
I don't
wow.
want to just, add restrictions to the point where they are as slow as a 6S setup, because then
Yeah. What's the
what's the
point?
point? Yeah. So I mean, and that's really, yeah, I guess they have a better efficiency, better top speed. But we tend to have, I mean, there are acceleration limits. There are, the motors coils, and there's magnetic fields that get saturated. And
Mm,
that once that happens, no additional voltage, no additional current is going to make that go any faster. It's just going to desync.
yeah.
And so we do have to start adding those into the firmware. And so that's one of the reasons for the experimental version firmware too, so we can give people more fine-tuned control over individual settings, and to especially slow things down and ramp things up a little bit better for the 12S setups. But
And
that's
hopefully,
coming in time.
and hopefully also allow manufacturers to do a little bit of that development work for themselves on their own setups, right? Like it might be that it's going to be the manufacturers who are going to be fine tuning stuff for those big, powerful setups, rather than maybe just you.
Yeah, yeah. No, it's keep an eye out for some of the stuff that TBS is coming out with. They're starting to get into some ESCs, and we've been working with them fairly closely, and they've been doing quite a lot of testing. It's really impressed me how much testing they do on their hardware before it gets released. So
Yes,
definitely keep
yeah,
an eye out for them.
I've heard a little bit about, I've heard a little bit about that project. So I can't say too much, but yeah, it's going to be fun.
Yeah, yeah,
Um,
definitely.
some of the stuff they're working on. Well, thank you so much. Thank you so much, Pete. It's been lovely to chat with you. I'm sure that everyone who watches this video will also enjoy it as well. And it's lovely to get to know you a little bit as well. Um, there's a nice personal side to it. And it's lovely to hear you talk about something that you're obviously so passionate about. So thank you so much for all of that. And thank you once again for your time.
All right. Take care.